My name is Sudarshan. Welcome to my channel EasyML. Let us now explore the second topic in data exploration, which is visualization. Remember this sample data from the introductory video? Well, for those of you who missed the introductory video, please click on the link provided below. Now let me draw your attention specifically to the data types. The types of visualizations we choose when we are exploring data often depends on the data types or heavily depends on the data type. So as an example for numeric data, let us take weight, and as an example for categorical data, let us take gender. Now, in this new slide, we can see that on the left, we have the visualization for numeric data, and on the right, we have the visualization for categorical data. The best way to visualize numeric data is through a histogram. Here, we can see a histogram of the selected variable weight. How do we interpret this diagram? Well, on the x-axis or the horizontal axis, we have the weights divided into bins, and each of these bins have a width of 5. Well, that is, if you can see, we have 60 to 65, 65 to 70, 70 to 75, and so on. And on the y-axis or the vertical axis, we have the frequency of observations that will be categorized into these bins. For instance, from this histogram, we can derive that 5 people fall within the weight range of 60 to 65 kgs. And we can also determine that the majority of the people fall into the weight range of 70 to 80 kgs. Hence, histograms help understand the range and the spread of the data given a particular numeric variable, which in this case is weight. We can also see that the so-called distribution is fairly symmetric. Basically, you can draw a nice bell shape around this diagram. Now, let us move on to the diagram on the right, of visualizing categorical variables. Here, we have a simple bar plot. On the x-axis, we have all categories in a given categorical variable. In this case, gender has only 2 categories, that is male and female. On the y-axis, we again have frequency or number of observations, in other words. The bar plot, usually helps understand the composition of the data. Well, in this case, we can check whether there is some bias due to gender. I guess there is some bias because there are more male observations than female. It can be observed. Now, what is the application of visualization towards machine learning? Well, understanding the distribution of these variables will help comprehend whether or not any prediction bias is likely to happen. So let us take an example. Let us say we are predicting a person's gender. Given that there are more male observations than female, the model is going to predict accordingly. Now, let us take a look at other types of histograms or distributions, in other words. We predominantly have 3 types: positive skew, symmetrical distribution, and negative skew. Well, positive skew, when we say positive skew, it means that we have an elongated tail towards the right. An example of positive skew is household income. For instance, in my house, my dad earns way more than me and my mom. Well, I guess this YouTube channel is a way for me to get back at him. Anyway, his income will skew the distribution heavily towards the right, hence the elongated tail towards the right. Now, let us move on to the next distribution, which is the symmetric distribution. As the name suggests, it is symmetric on both sides, so there's no skewness per se. An example of symmetric distribution would be appraisals in an organization. At least appraisals in my office are done in order to fit this distribution. Or even the distribution in the previous slide, which is the weight example, this is also fairly symmetric, as you can see here. So this is also an example of symmetrical distribution. Now, when it comes to negative skew, so negative skew, as the name suggests, is the opposite of positive skew. So there is an elongated tail towards the left. An example of a negative skew distribution would be gestation period. So, I mean, on an average, babies take about 9 months to be born. but there are cases of premature babies, miscarriages, etc., and those cases will tend to cause the skewness towards the left. This is just some food for thought, and this brings us to the end of visualization. In the next video, we will explore the last concept in data exploration, which is normalization. So stay tuned. Thank you.